I'm going to talk today about some empirical evidence pertaining to the unilateralist's curse. Could I just see a show of hands of who has heard of the unilateralist curse before? Okay, pretty good. All right. So maybe some people haven't, but anyone who has heard of it, I'm just gonna confuse you enough so that you're all on the same page, and then I'll just take it from there. Okay. All right. So essentially, the unilateralist curse is about times where it just takes one individual to mess things up for everybody else. Okay. So for example, in 2023, Facebook's large language model, Llama 2, had its weights leaked on 4chan. So it only took one of Facebook's customers to do this. And then after that, there's kind of nothing anyone else could do about it. It's the weights are now public. So this is an example of a kind of unilateral decision, which many people could have done. Similarly, in 2016, a team of bio researchers successfully synthesized the horsepox virus. By the way, if it's not obvious, that's a bio researcher. I created that without the help of generative AI. So I hope you appreciate it. Okay, now much as kind of with the model weights case, it only takes one team of researchers to kind of publish this synthesis to give a proof of concept that this kind of dangerous virus synthesis is possible. And there's not really anything any other team of researchers who could have done it but chose not to can do about this. So in all these cases, there were many people who could unilaterally and irreversibly impose the same event. So this is the kind of situation that we're interested in here. Okay, so there's many reasons for this, but it's generally bad news when many people can impose the same event. People might impose it for bad reasons, such as just being overconfident that they are correct about what is the right thing to do. They may impose events out of malevolence, or they may just be bad incentives, such that they're greedy and therefore they impose an event that benefits them but that doesn't benefit others. But the point of the unilateralist curse is that even when everybody who can potentially impose the same event are altruistic and well calibrated with respect to their evaluation of the event that they can impose, it's still bad news. Okay, so I'm going to focus on this more optimistic situation in which people's judgments are good and they're vaguely altruistic, or at least their goals are aligned. Okay, so kind of before I start on the bad news, there is some good news, which is if people can communicate, the problem's not too bad. So essentially, you can just make a joint decision in a kind of majoritarian way, pooling the evidence. So for example, Leo Szilard was the scientist who conceived of the nuclear chain reaction. And here's his report of how he and some fellow physicists discussed whether they should publish some of the physics of the chain reaction. He says, "We met to discuss whether or not these things should be published. Both Teller and I thought that they should not. Fermi thought that they should. But after a long discussion, Fermi took the position that after all, this was democracy, and if the majority was against publication, he would abide by the wish of the majority." Okay, so this is nice because you can see that if every scientist had made the decision on their own, it's likely that Fermi would have published, and therefore the physics of the chain reaction would have been public, such that perhaps it would have helped Nazi Germany create the bomb before the US did. But in fact, because they discussed it and they kind of pulled their opinions together, they ended up refraining from publishing it. And in hindsight, that seemed like that was a good thing. Okay, so the bad news is, of course, that communication is not always possible. So, for example, in the case of the Facebook AI customers, it's not obvious that they could have all discussed whether to leak the model together, or if it's kind of realistic that they did. It's probably one person who just took it upon themselves to leak it on 4chan without discussion. Similarly, if you've stumbled on a research finding which has potential for misuse, it's not obvious that you're going to know who else has discovered the same finding, and certainly not who else will discover it in the future. So this makes it very hard to coordinate in this way. Okay, so unilateralist curse is really about what will people do if they cannot communicate. So let's use horse box synthesis as an example. And to keep things very simple, I'm going to imagine that there are 20 independent researchers who've all discovered how to synthesize it, or at least could do so. Any of these researchers can publish the synthesis. And now let's just assume this kind of very optimistic scenario that they all want what's best for society, but they might have different evidence about what is in fact best for society. So they may disagree on whether horse box synthesis is a good thing or not. Okay, so here is the naive way to decide. Everyone could just consider on balance whether they think in expected value terms the synthesis is on net good for society or not. And therefore, even if they think it's ever so slightly good for society, like the expected value is like, you know, £1 or something, that's enough, and they can publish it. Okay, so I'm going to refer to this as kind of a naive decision as usual strategy. The reason I call it decision as usual is that if you are kind of deciding between two options, typically you just you want to choose the thing that has better expected value, right? So that's why I call it decision as usual. So this strategy is not crazy, kind of for the reason I just said, but it's also not optimal and it's not great. Essentially, if there are many people who can impose an event and they all decide like this, it's just quite likely that at least one of them will think that the event is positive in expected value terms, even if it's not. So it's very likely to get imposed, and in the case of horse box synthesis, very likely to get published. Okay, just to give you an example, you can see like 19 of the 20 researchers here. Now let's suppose that most of them think it's a bad idea to publish the horse box synthesis. Okay, so most of them, when they're asking themselves, do I think it should be published? They're like, on balance, no, I don't. But now there's one person, this guy again, who thinks, yeah, maybe. I don't know, it's pretty close, but you know, it's benefits for science and so on. They think it's a good idea. Okay, so in this world, when everyone's deciding like this, it gets published, even though there's like a 19 to 1 majority against. So this illustrates the unilateralist curse, where many people can unilaterally impose the same events, and they all decide altruistically based on their private evaluation of that event's value. That event's going to be imposed too often. So that's, of course, from a 2016 paper by Nick Bostrom and colleagues. All right. So what's the kind of rational way to avoid the curse when you can't communicate? Essentially, you want to engage in a form of conditional reasoning. You basically decide as if you knew your decision would matter. And in a simple case, that approximates basically evaluating the expected value of imposing the outcome, which is distinct, of course, from the expected value of the event itself. Okay, so yeah, in the kind of winner's curse literature, this kind of reasoning is typically known as conditional reasoning or contingent reasoning, but it basically takes into account how your evaluation of the event would change if you knew that your decision was going to matter. Okay, so I'll take you through the example with horse box synthesis. Again, you want to decide if you knew your decision should matter. So there's two worlds you could be in. There's one world in which someone else is going to publish the finding anyway. Okay. In this situation, by the way, that's evidence that it's a good thing, right? If more people are willing to publish it, that should kind of increase your confidence that it's a good thing that's published. But of course, in this situation, your decision doesn't matter. Like, it's going to be public anyway. Someone else has imposed the event. It doesn't matter at all what you do. The synthesis is going to be public. Okay, so you don't need to think about this. There's another world you could be in where nobody else publishes the finding. Okay, in this case, your decision matters. But of course, if nobody else is willing to publish the finding, it suggests that perhaps your intuition that, you know, this finding is a good thing, or publishing it would be a good thing, perhaps that intuition is wrong. So even though you might think it has positive expected value, knowing what you do, if you knew that nobody else was going to publish it, you might then like update such that your expected value of actually publishing the thing is going to be negative. Okay. So this kind of reasoning should help. So this is the kind of naive decision as usual case I showed you before, where most people think it shouldn't be published, but one person does, it still gets published. If everyone uses conditional reasoning, the hope is that it looks more like this. So Again, everyone who wouldn't have published before still doesn't, because they're thinking, well, would I publish if nobody else does? Obviously not. I didn't think it was a good idea anyway. And then the one person who was, open to publishing, thinking it might be a good idea, now they're thinking, well, would I publish it if I was literally the only person to? If everybody else thought it was a bad idea, hopefully they're not so confident that they do that, right? So in this case, the curse gets mitigated. Okay, so it turns out that this is kind of the optimal strategy in this case. It's individually rational so that, everyone is incentivized to do this kind of reasoning. And if everybody does it accurately, then the Nash equilibrium is socially optimal. So if everybody is like behaving optimally, assuming that like no one else is going to impose the event, you should reach the socially optimal outcome. The best you can do, given that you can't pull information. So here are our research questions. Firstly, we're actually going to test whether people impose too much. Like it could be that people have intuitions that just approximate this kind of conditional reasoning, or it could be that they don't, and they just follow a more naive decision as usual strategy. We're also going to look at kind of what interventions there might be to mitigate the unilateralist curse. And more generally, what kind of psychological factors might counteract any naive tendency just to impose any outcome that seems positive. Okay, and we're also going to, at the end, I'm going to show you some results with a sample of AI researchers. All right, so first question is just, do people impose too much? To test this, we wanted a situation in which we knew what was the optimal amount to impose outcomes. And so we created an economic game, meaning we basically recruit a bunch of lay people to take a survey, and then we have them play a game with each other, and we set the rules such that we know what's the optimal amount to impose some outcome. And they're incentivized to kind of behave rationally because we give them bonus payments according to their performance. And I'll explain to you, I'll show you now the instructions that participants saw, or at least a simplification of them. So we tell them that they're playing a game with two other people. So there's three people who can impose the same event in total. Now we tell them that together as a team, they're going to open one of two boxes, box A or box B. So one of these boxes contains 50-cent bonuses for each player. And this is, they would actually get those bonus payments if they chose the right box. But of course, they don't know which box contains the money. And importantly, this is kind of where the asymmetry comes in, or where the imposable event comes in. The rules for opening either box is different. So by default, the group is going to receive the contents of, let's say, box A, okay? But if any one of them decides to open box B, then instead they all get the contents of box B. So, I mean, we counterbalance which box is A and which box is B, but the idea is this one box is kind of the imposable event. Anyone can choose that box, in which case the whole group gets that box and there's nothing anyone else can do about it. Okay, so we're going to give them some information, some clue as to which box might contain a bonus. And we're going to do that independently. So each player is going to get an independent signal that only they can see, which gives some evidence as to which box contains the bonus. So we're going to do this in, I think, a relatively simple way. So step one, for each player, a survey is going to draw some random integer from 51 to 100. And this is just going to represent the percentage chance that the signal they see is accurate. Okay, so step two, after they've drawn the number for each player, they're going to decide whether the signal is going to show the correct box or not. So for example, if, say, the random number drew 75, that means there's a 75% chance the signal is going to be correct, which means that the survey will decide with 75% frequency that it will indicate the right box, and with 25% frequency, it will show the wrong box. Okay. So, and then participants are going to actually see their signal, and they see the level of confidence that it has. So this is all completely accurate. The signal says that, in this case, the signal will say there's a 75% chance that box A, for example, contains the bonus. Okay, so the participant knows the accuracy of their own signal. They don't know what signals other people see, but they do know that they get signals generated with the same process. And we like ask them a ton of comprehension questions about this, so they understand all the instructions. And typically about 70 to 75% of participants understand all the comprehension questions and all the instructions, and are only going to analyze data with those participants. Okay, so you get the idea. So what should players do? So of course this is not trivial, and this is going to be extremely hard for participants to calculate. So we're not going to expect them all to be kind of play exactly optimally. But essentially, if everyone is behaving rationally, the best thing that everyone should do is basically impose the imposable box only if their signal indicates it contains the bonuses with 75% certainty or more. The intuition for this is something like, okay, so they need to be thinking conditionally. They need to be thinking like, what's the right decision, assuming that everybody else decides not to impose. In this case, if everyone's imposing, if and only if their signal is 75% sure or more. If the other two people haven't imposed, that suggests that both of these people's signals were like either indicating the other box or indicating the imposable box with less than 75% certainty. So that's some evidence against the imposable box containing the bonus. But if my signal's 75% sure that that box contains the bonus, that's enough to overcome that evidence, basically. So on balance, the signal is just strong enough such that I should impose. And if it's any stronger, I should certainly impose. Okay, so this is just like what falls out of conditional reasoning applied properly. Again, I don't expect participants to be able to calculate this, but one would hope that their intuitions are going to kind of somehow, the errors aren't necessarily going to be in any direction, right? Like they could overestimate like how cautious they need to be, or they could underestimate it in principle. Okay, so first, I'm just going to show you how many people actually end up imposing after seeing their signal. So the y-axis there is just, the percentage of people who impose. And by the way, the only interesting participants here are those whose signals indicated that it was more likely that the imposable box contained a bonus. The other people I'm just ignoring for now. Okay, so first I'm just going to show you how many people should impose. So this is just literally how many participants saw a signal that was 75% strong or more in favor of the imposable box. And just by chance, it happens to be about 45% of them did. Okay, so now I'm going to show you how many people actually imposed after seeing their signal. Okay, so it turns out to be about 70%. So many more than whose signals justified it. So this is initial evidence that like after people see a signal which says that they should, or like the imposable box more likely contains the bonus, they're kind of much more likely to impose than they should, even when their signal is like slightly below where it needs to be. And just as an aside, like when I say, okay, you need to be 75% sure at least, that's of course assuming everyone else is playing the same way. If people are less cautious, then you need to be much more cautious yourself, okay? So if everyone is kind of like, 55% sure is fine, then like you need to be really, really sure. Okay. All right. So first thing we've shown in this relatively conservative case, there's only two other players, people are still imposing too much. So we're going to see, are there kind of any simple interventions we can use? So one thing that we tried, which is very simple, is just asking the same question slightly differently. So rather than having them see their signal and then decide whether to impose, in which case there's a kind of just a strong intuitive pull to impose, given your signal saying that the imposable box probably contains the bonuses. We try and circumvent that by, before they see their signal, asking them how strong it would need to be in order to impose. Okay, so again, this is intended to preempt the drive to just follow your signal. So in this same experiment with the data I just showed you, we randomly assigned another group of participants to decide in this way, right, with the threshold. So I'll tell you a bit more about how that works. Basically, before they see the strength of their signal and which direction it points, we just basically ask, how certain would you have to be that the imposable box contains the bonuses in order for you to impose it. Okay, and then this answer is going to determine the final decision. So after they make this judgment, then we randomly generate the signal. And then if, basically, so for example, suppose they said, okay, I'll impose if my signal is 75% strong or more. They then will impose automatically if their signal is at least that strong, suggesting the imposable box. If it's less strong, they automatically won't impose. So basically, they're committed to kind of honor this threshold. Okay, so let's see when people decide in this way whether it affects the amount of people who impose. So this is just the same data that I showed you before with this kind of binary decision. You see your signal and then you decide whether to impose. We had 70.6% of people imposing versus 45% or so who were justified in doing so. With the threshold dependent variable, just by chance, ever so slightly more of them had a signal that was 75% sure or more. So let's see if a similar amount of people impose or not. Turns out far fewer people impose. So when people actually have to decide their threshold in advance, in this case, there is no unilateralist curse. So people are in fact cautious enough. Okay, so basically what's happened is it's just circumvented that kind of obvious drive and intuition that if my signal says it's more likely the imposable box contains the bonus, I should just impose that box. Okay, this isn't a silver bullet, by the way, and I'll show you like how fragile it is later. And one other thing to remember, by the way, is that in this design, just to keep things simple, we made one box kind of default, and the imposable box was kind of a deviation from the status quo. Generally, people don't like deviating from the status quo. So in some ways, this design is kind of stacking against the odds against the unilateralist curse, if that makes sense. So it's only kind of in this very unique situation. There's barely any other imposers. We use this kind of threshold elicitation of whether to impose or not, and the status quo is not to impose. Is when we manage to like mitigate the curse entirely. Okay, so recap. So far, people usually impose too much, but not if they kind of pre-commit to this minimum certainty threshold. Okay, follow-ups. We want to know what happens if there are more potential imposers. Like, there's only 3 people, the curse isn't too bad. We want to also know something about what happens when the stakes are higher or lower. And we want to know something about what psychological factors might mitigate the curse. All right. So in study 2, we employed a very similar design with just a few differences. So again, it's a similar game, and there's 2 boxes. One's default, one's imposable, and each participant has a independent noisy signal generated in the exact way that I described before. So anything from 51 to 100% certain. So this time, we manipulated the group size. So in one, we had one set of participants have a group size with only 2 other potential imposers. In the other condition, we had 20 other potential imposers. Okay, so we're going to see how sensitive they are to the size of the group. The unilateralist curse is much worse with 20 other imposers, and you need to be much more cautious in that case. Another thing we did is we manipulated the stakes to either be low or high. Now, I know 1 cent and $1 don't seem like super high stakes. We did actually do the first and last study we did with this. We actually had higher stakes, either 50 million or $50. So 50 million, 50 or 50 million. But this was hypothetical. This is not where the FTX consumer deposits went. This is yeah, just a hypothetical study. Okay, this one was real though. This we can afford. Okay. All right. So rather than having the binary choice DV, we had them all make this kind of threshold judgment. It gives us a little more granularity. All right. So first, I'm going to show you how people respond to group size. This is no longer the percentage of people imposing, by the way. This is now basically what threshold people required to impose. So now this is a kind of a measure of how cautious people are, right? The higher up you are, the more cautious you are. Okay. So first, I'll show you the optimal level of caution in both cases. So as I mentioned before, with 2 other players, you need a signal at least 75% strong to impose, at least assuming everyone's rational. So that's like a best case scenario. Otherwise, you should be more conservative. In the case of 20 others, you need to be much more confident. So why is that? Well, you need to be behaving as if you knew that your decision would matter, right? So if there's 20 others, your decision only matters when all 20 of them have decided not to impose. So all 20 of them don't have evidence strong enough. That should update you a lot against imposing. So your own signal needs to be really, really strong to overcome that. And it turns out that a signal of 94%, or 95 maybe, is strong enough, given that everyone else is using the same rule. Okay, so first I'm going to show you the distribution of responses when there's just two other players. So this is going to shock you, but I'm going to show you a whole distribution. I'll show you how it looks, but it's nice to see kind of how the range of people behave. All right, so here you go. So remember the blue line that shows kind of what people should be doing. Each dot represents a different participant, but like you can get a rough sense of the distribution just by looking at the outline here. So you see it's kind of it's not that bad. I mean, it shouldn't be surprising because again, it's what happens when there's only two other players and we're using this threshold DV. So people are pretty good. What you see is that of course people are not calculating this, right? That there's very few people, or not that many people at like around 75%. But there's a few people who are kind of, you know, their instincts seem to be okay, right? They're not too far. And then there's people at the very bottom here, right? There's people who are literally using the most naive kind of decision as usual strategy. 51% is enough. Not that many of them, but they exist. And there's also people, by the way, at the top who are extremely cautious. They're like, I need to be 100% sure to do it. So it's interesting. You get like a really kind of wide range of responses here. Okay. So I'm going to show you what the distribution looks like for 20 others. So remember, they should be much more cautious here, right? They should be right at the blue line. Okay. So basically, the distribution looks almost exactly the same. Almost exactly the same. Okay. So you can see the mean. It is actually, by the way, ever so slightly higher. And by the way, what makes this even more extreme, by the way, is that this isn't a different group of participants. We had each participant play the game in total 4 times. 2 of those times with only 2 others, and 2 of those times with 20 others. Right, so it's not like, oh, they're just kind of, it's some kind of scope and sensitivity. If they understood the game, okay, we're back. Amazing. Yeah, if they understood the game, right, they would at least be more cautious the second time, even if like they're absolutely like they're kind of the levels weren't right, but not even that, or at least not by a large amount. So you can see almost the whole distribution is below where they need to be. And yeah, basically it looks the same. Okay. So what does this tell us? So people, whatever they're doing, they're not using conditional reasoning. They're not using this pure decision as usual strategy either, at least not when we give them this threshold dependent variable. I think many more of them probably do. When they just make their decision after seeing their signal. Okay, so something else is counteracting the kind of tendency to impose and just do like whatever their signal seems to suggest. So this is getting a bit more speculative now, but we try to dig into the psychology of kind of what counteracts the unilateralist curse. Our hypothesis is some form of responsibility aversion. So people don't seem to like being the person who is solely responsible for whatever happens. Now, why does this deter imposing? The only way you can be solely responsible for the outcome is if you impose. If you decline to impose, if nobody else imposes either, well then you'll have shared responsibility for getting the non-imposable outcome, right? Whereas if you impose, I mean, if everyone else imposes too, that's fine. But if no one else imposes, well, then it's all on you. Like whatever happens is completely your responsibility, and that can be quite a daunting prospect. Okay. So just consistent with this, we measured people's concern about kind of being the only one to impose, and indeed that predicts greater thresholds, right? That predicts more caution, just correlation-wise. But so one important thing is that it deters imposing like less effectively when there are more other people who can impose. Okay, so why is that? Well, basically, someone else is going to do it anyway, right? So like I'm quite unlikely to have sole responsibility when there are lots of other people who can impose. So basically the intuition's like, okay, well, someone's going to do this. This thing's going to happen. I just want to be on the right side or something. I just want to like do what my best guess is. Okay, so that's what people seem to do. By the way, this is going to be different if there are other costs and benefits to imposing. Okay, in this situation, all that matters is getting the right answer. Right? There's no like kind of private benefit necessarily, although maybe there is, you know, in terms of how people feel. But yeah, so that's important. This is it's basically when there's kind of no other costs and benefits, when someone else will do it anyway, you're just going to kind of follow your intuition. Okay, so remember we measured responsibility concern, we used 2 items. This y-axis here is just like how concerned they are about being solely responsible for the outcome. And I'm going to show you like how concerned they are with 2 others and 20 others. Okay, so with 2 others, I mean, they're not too concerned, but with 20 others, they're even less concerned. Okay, so basically this like concern about responsibility, it helps more when there are fewer people who can impose. When there are more people who can impose, it's less helpful, which means it's basically only really useful in the case where there's few imposers. Okay, so we wanted to get a more causal evidence that this kind of sense of responsibility matters. So basically, this is what the manipulation of prize money was about. So again, either the prize money is 1 cent per participant or is $1 per participant. The expectation is people are going to be more averse to like responsibility when the stakes are higher. Okay, so we did a manipulation check of this. And you can see that basically with 1 cent bonuses, people are less concerned than when there are $1 bonuses. So it's a small effect, but like we are successfully affecting some people's sense of responsibility here. Okay, so let's see then what this means for how cautious people are in the game. So on the left, I have people or decisions that were made with only like 1 cent stakes. On the right, people who made decisions with $1 stakes. And I'm going to show you distributions again, but first, I'm averaging this, by the way, or I'm including both people's decisions, both for like with 2 people and 20 people here. So on average, they need to be 84% sure. Okay, so with the 1 cent bonuses, so on average, they need to be around 74% sure, so they're not nearly cautious enough on average across the 2 cases. Now with the $1 bonuses, you can see that they are slightly more cautious. So they're not quite as cautious as they need to be on average. Of course, that's driven by the 20-person case. But on average, their thresholds are, you know, closer to around 77%. Okay, so higher stakes does to some extent increase caution about imposing. Okay. So implications, responsibility aversion seems to mitigate the kind of tendency to impose. Unfortunately, it helps less when more people can impose, right? So it doesn't really help in a situation where there's many people who can impose the same outcome. Very obvious implication, which you probably thought anyway, but policymakers need to limit the amount of people who can impose risky outcomes when the stakes are really high. Okay. Fortunately, responsibility aversion at least helps more when stakes are higher. And that does mean that it's really important that decision makers who can impose understand when stakes are high, and potentially, you know, if they're not that altruistic, they need to be incentivized as such, right? So you need to make the stakes high for them. Okay. All right. So now I'm going to move on to some empirical evidence about actual AI researchers. Okay. So supposedly, not even supposedly, these are extremely sophisticated, statistically sophisticated people. So they certainly have the capacity to understand the unilateral curse. All right. Oh my God, it's that guy again. Anyway, okay, we have, he's now an AI researcher. All right, so we recruited 200 AI researchers. So we asked them about a kind of hypothetical situation in which they could kind of unilaterally and anonymously publish some finding that would increase some risk from AI. The ones we used, for 50% of participants, we used the risk of AI that could suffer, and for the other 50%, we used the risk of creating dangerous AI. Okay, so we gave them some kind of other stipulations, like they couldn't communicate and they had to make the decision at the same time and so on. And then we asked all of them this question, and we asked it twice again. So each participant sees two versions of the question, one with only 2 other researchers, one with 29 researchers. Okay, so we just ask this kind of threshold question again, like how certain would you need to be that the societal benefits outweigh the risk in order to publish this finding? All right, so I'll show you results here. So this y-axis again is people's thresholds for how certain they need to be in order to publish. So it's a measure of caution. Higher levels mean more caution. Okay. So first I'll show you 2 others, then 29 others. In this scenario, we don't know what the right level of caution is, by the way, right? So I'm not going to show you what the correct answer is. The only way of seeing if they're doing conditional reasoning or not is seeing whether they update from the 2-person case to the 29-person case. If they're doing conditional reasoning, then when there's 29 people, they should be thinking, oh God, I have to be really sure. I mean, my decision only matters if no one else publishes. If 29 others don't publish, I should be really sure. So I should be more sure than in the 2-person case. So in the 2-person case, when there are only 2 other researchers, people need to be around 80% sure. By the way, this is very sure, right? So like it's kind of surprising to me, especially like, I don't know, I have some stereotype about AI researchers that perhaps they're kind of pro science and advancement and so on, but they're saying they need to be actually like 80% sure that the societal benefits outweigh the costs in order to publish this thing that has these risks. So that's kind of good. Again, it suggests, I don't know, maybe it's responsibility aversion, but at least there's some level of caution. Now, I mean, unfortunately, there's absolutely no difference when there are 29 others. So there's no sign of any conditional reasoning. By the way, another thing we did, of course, I don't have the data here, but we looked at the percentage of people who either go up or down, and the large majority of people just give the exact same answer both times. There's about maybe 10-ish% of people who do like increase their level of caution with more others, and there's about 10% of people who reduce it. Okay, so they completely cancel out. Okay, so to recap, AI researchers fail at conditional reasoning, right, which seems somewhat concerning. We've also done similar studies with other sums of interest. I'm not going to go into details, but I'll summarize. So firstly, we did something with lawyers and judges, where we looked at a case in which some kind of bio-research company wanted to have like legal permission to do some research, and they were like asking, like they were kind of appealing in multiple state courts, and if they could do their research in any one state, that kind of like that influences the whole world, right? That kind of imposes the research on the whole world. Okay, so there's multiple courts deciding this. Basically, people don't use conditional reasoning, and any judge says they need the exact same degree of certainty, whether they're one of only like 3 courts deciding or the only court deciding, as when there are like many courts deciding. Okay, so this I don't think is very surprising, but like kind of legal experts, lawyers and judges don't seem to have any notion that they should incorporate conditional reasoning into their judicial decisions. Okay, we also kind of tested another kind of unilateral decision, which is using a veto, right? So when you veto a motion, you kind of unilaterally impose that motion fails. And so we wanted to see if like these were like US elected local government officials. We wanted to see if they would use this kind of reasoning. I mean, basically ask them like, would they veto a motion, like, or how certain would they need to be given that they knew no one else would veto, or given that they didn't know how others would behave. And basically, people are much more cautious when they know no one else will veto, and much less cautious when they don't know. Of course, if they're doing conditional reasoning, it should be the same, right? But like, in fact, they're a bit more like, trend following, even when the vote's supposed to be anonymous. Okay. Finally, we also asked a situation like we asked doctors about like a situation in which there are multiple doctors treating the same patient. You can imagine someone like, I don't know, like looking for some medication and going from doctor to doctor and asking each doctor for the medication. When there are more doctors who can potentially treat the patient, each doctor has to be more cautious about whether they provide the treatment. And of course, that's not what we find either. So doctors are completely insensitive to the number of people who can prescribe the same treatment. All right. So I'm going to talk about the gist of the policy implications from this. First caveats. Conditional reasoning, of course, is necessary to make appropriate like judgments in unilateral situations. It's not sufficient. Like other important factors, obviously there's self-interest. If people have bad incentives and they're self-interested, that's going to be a problem. If people are malevolent, that's potentially even bigger a problem. If people just are overconfident, that's also a problem. So like maybe people would still impose events even if they know everyone else disagrees with them and they don't update on other people's information appropriately. That would also be bad. Okay. There's also like the possibility that people just don't know that there are other potential imposers. I mean, in the scientific research case, this is very easy to imagine. You might think you're so special, you're the only person to have found something. In fact, many other teams might do so in the future. Finally, decisions are just hard, right? So sometimes there's going to be some really important decisions for which our evidence isn't that great, right? And there's not that much we can do about that. Okay. Final thing for this research specifically is that like we don't know generalizability from vignettes to the real world, and we don't know generalizability from these economic games to the real world. So we do our best to use a variety of samples and a variety of scenarios, but that's still a caveat. It's really hard to know whether people are imposing too much or not enough in the real world. Okay, so that said, I'll talk about the tentative policy implications. The most obvious one is just to the extent that you can influence how many people can unilaterally impose something, we want to limit the number of people. So one like classic example of this is like sole presidential authority for launching nukes in the US. So that's not perfect by any means, but it's better than a situation in which lots of generals, like say that, the army can unilaterally launch and the navy can unilaterally launch them. That would be worse. Okay. In other contexts, you can imagine like trying to limit research grants to only for like dangerous research to only a few labs. You can imagine like preventing the democratization of like DNA editing technologies, giving licenses to build and open source AI models and so on, right? So like there are some policy levers in these cases. All right. So softer things, more like nudges. It seems important that people understand when stakes are high, because higher stakes does seem to make people more averse to imposing events and offset the unilateralist curse somewhat. So maybe this could take the form of kind of training for I don't know, government officials or scientists with access to sensitive information. In certain cases, you could try and incentivize people, like make the stakes higher for people just by incentivizing them. So to some extent, like tort law does this, like if people can be sued, they're going to be more careful. And you could imagine compensating people according to the quality of their decisions and so on. Okay. So another thing that seemed to work or seemed to make a big difference was when instead of just having people see their evidence and then deciding, we had people in some sense pre-commit. So they would decide how much evidence they needed before imposing. Implementing this in real life seems like it might be difficult and will depend a lot on the situation. In military context, you can imagine some wargaming, like how much evidence you need before you launch a nuclear weapon or something. Hopefully people commit to that in advance. You can also imagine just like checklists and other situations, like checklists for the evidence you need and so on. So there are some things you can imagine doing to try to kind of mimic this kind of threshold decision. Okay. So I also want to talk about some implications for like thinking about what's effective to do or how to effectively improve the world, altruistic interventions are a little bit like unilateral actions in some sense. So just as imposing outcomes has more impact if no one else imposes, investing in a given cause has more impact if that cause is more neglected, but presumably, because there's diminishing returns to investment or something like that. Similarly, just as no one else imposing an event suggests that the imposable outcome is bad, neglectedness is some evidence that a problem is either not tractable or not important. Okay, so of course, a good heuristic for deciding like how impactful it is to work on a problem is to think about how important that problem is, how tractable it is, and how neglected it is. And essentially, you kind of multiply those components together to get a sense of how much impact you can have by working on it. So this is great. It's particularly okay if like you are not uncertain about how important something is, and you're not uncertain about how tractable something is. If, however, you are uncertain about those things, then really what you're doing when you're assessing importance, tractability, and neglectedness, you're doing something like expected importance, expected tractability, expected neglectedness. Okay. Now, that's basically a form of like kind of naive decision as usual, right? You're not thinking conditionally. And why that matters is, well, let's say you're uncertain about importance. It could be high or it could be low. What you might expect is that problems that in time reveal themselves to be important are going to attract more resources. So they're going to be less neglected, right? And like future neglectedness matters, right? Because like we don't need to intervene on something if someone else is just going to do it later anyway, right? So like this is a slight caveat maybe to the kind of ITN framework, which is that when you are more uncertain about importance and you think that future neglectedness will track how important a cause reveals itself to be, then you're going to somewhat overestimate the effectiveness of a cause if you just naively use this ITN framework. And the evidence that people aren't sophisticated at this conditional reasoning suggests that in practice, people aren't going to be that careful about interpreting the ITN framework. And so it's just something that we should be looking out for. All right. To summarize, it seems that people unilaterally impose outcomes too frequently in general. But also, people are somewhat adverse to having sole responsibility for whatever outcome arises, and that means that gives some incentive for people not to just impose any event that seems to have positive expected value. However, people seem, without nudging, like completely incapable of conditional reasoning, and that includes statistically sophisticated populations such as AI researchers. Absolutely no sign of conditional reasoning. Okay. So we did suggest some interventions, such as limiting who can impose and trying to increase people's sense of concern about responsibility. With that, I'm just going to firstly thank my co-authors, and otherwise I want to thank you guys for listening. So thank you.